Okay, everybody, welcome to section 12.5. This section is all about tree diagrams. So you're going to learn some counting principles. You're also going to learn how to construct a tree diagram. First is a counting principle, which is a simple multiplication rule. So if a first experiment can be expected to or can be performed in m distinct ways, and a second experiment can be performed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. Another term you need to know is the term sample space. A sample space is a list of all possible outcomes in an experiment. You also have the term sample point. Sample point is each individual outcome in the sample space. And last, tree diagram. Tree diagrams are helpful to determine your sample spaces. So let's look at an example. Example 1. 2 balls are to be selected without replacement from a bag that contains 1 red, 1 blue, 1 green, and 1 orange ball. A. Use the counting principle to determine the number of points in the sample space. So essentially, they're just asking you how many items will you have in your sample space. So keep in mind that you are selecting 2 balls. So there's 2 events. You have event 1 and you have event 2. There are 4 different kinds of balls in this bag. There's a red, a blue, a green, and an orange. So for event 1, how many possible outcomes are there? There's 4 possible outcomes. Now, you are going to take the ball out and not put it back in the bag. That means you've eliminated one of the balls. So for event 2, when you go to select the second ball, there's only 3 possible outcomes. So according to the rule, you can just take your 4 times your 3. There will be 12 items or 12 points in your sample space. Question B. Construct a tree diagram and list the sample space. So the first thing you have to do is you have to figure out what is going to occur on your first selection. So when you first pull from the bag, you could draw a red ball, you could draw a blue, you could draw an green, or you could draw an orange. So there's 4 possible outcomes. Then you have to worry about what happens on the second draw. So for example, if we drew a red in our first draw, then that means on the second draw, there's only a blue, a green, or an orange left to pick. So if you were listing your sample space, your first 3 outcomes is that you could have red blue, red green, red orange. Then you have to go to the next option. Maybe you drew a blue on the first draw. So if you drew a blue ball, that means there's a red left in the bag, a green left in the bag, or an orange left in the bag. So you could draw blue red, blue green, blue orange. Maybe you drew a green ball on the first draw. That means there's a red, a blue, and an orange left. So that means you could have drawn green red, green blue, or green orange. Last, you could have drawn an orange. So that means if you drew an orange, there's a red, a blue, and a green left. So your possible draws for orange could be orange red, orange blue, or orange green. So if you went through and counted all the items in your sample space, you should count a total of 12 items, or 4 times 3. Question C. Find the probability that 1 orange ball is selected. Okay, so remember when you're finding probability, you want the probability of the orange balls divided by the probability of all the items in the sample space. So the easiest way to do this is to look at the tree diagram that you just created. So I have a picture of the tree diagram here. Now, Our favorable event is to get one orange ball. So if you're looking at your sample space, you are looking at the items that only have one O in it. So that could happen from red orange, blue orange, green orange, orange red, orange blue, or orange green. So there's 1, 2, 3, 4, 5, 6 favorable events. There are 6 ways to draw one orange ball. How many items are in the sample space? There was a total of 12 items in the sample space. Remember to always reduce your fraction. The reduced fraction of 6 over 12 is 1/2. So you have a 50% shot of drawing an orange ball from the bag. Question D. Find the probability that a green ball followed by a red ball is selected. So again, if you have created your sample space, you are looking for the green-red option. So you want green first, red second. There's only one item in the sample space that has green first and red second. There are 12 total items in the sample space. So the probability of green and then red would be 1/12. Let's try another example just to make sure that we're all on the same page. Okay, example 3. A radio station has 2 tickets to give away to a Bon Jovi concert. It held a contest and narrowed the possible recipients down to 4 people. Christine, we'll mark her with a C. Mike Hammer, he's going to be MH. Mike Levine, he's going to be ML. And Phyllis, she's going to be P. The names of the 2 of these 4 people will be selected at random from a hat, and the 2 people selected will be awarded the tickets. Question A. Use the counting principle to determine the number of points in the sample space. So again, we're going to do 2 selections. So we have to find out how many people are possible for selection 1 and how many people are possible for selection 2. Then we're going to multiply those together. So there's 4 people. There's Christine, Mike H, Mike L, and Phyllis. So there's 4 people that we can choose to win the tickets for the first draw. Now you're not going to give the ticket to the winner again, so for the second draw there's only 3 people. So if you multiply those together, you will have 12 combinations in your sample space. Question B. Construct a tree diagram and list your sample space. So this is going to be very simple. We need one for draw 1, and we'll need another one for draw 2. So on the first draw, Christine could have won first, or Mike H could have won first, or Mike L could have won first, or Phyllis could have won first. What will happen on the second draw? Well, on the second draw, if Christine won first, then that leaves Mike H, Mike L, and Phyllis. So 3 possible combinations of winners could be Christine and Mike H, Christine and Mike L, Christine and Phyllis. There's your first 3 options. Well, maybe Mike H won first. So if he won first, then Christine could win second, or Mike L could win second, or Phyllis could win second. So your next 3 combinations could be Mike H and Christine, Mike H and Mike L, Mike H and Phyllis. There's 3 more possibilities. Well, maybe Mike L won first, so that means Christine could win second, or Mike H could win second, or Phyllis could win second. So 3 more combinations. Mike L and Christine, Mike L and Mike H, Mike L and Phyllis. Well, maybe Phyllis won first, so that means Christine could win second, or Mike H could win second, or Mike L could win second. So the last possibilities are Phyllis and Christine, Phyllis and Mike H, and Phyllis and Mike L. So there's 12 different ways the tickets can be distributed. Question C. Determine the probability that Christine is selected. So again, let's just look at our sample space and let's find all the ways that Christine is the winner. So Christine in first, Mike L second, Christine first, Mike H second, Christine first, Phyllis second. So there's 3. You could do Mike H and Christine. You could do Mike L and Christine. And you could do Phyllis and Christine. So there are 6 different ways for Christine to win out of 12 possible ways total. So Christine has a 50% chance in winning. Not bad. Question D. Determine the probability that neither Mike Hammer nor Mike Levine is selected. All right, so let's look at our sample space and find all the ways that Mikes do not win. So if Christine and Phyllis win, no Mikes were included. And if Phyllis and Christine win, no Mikes were included. So there's only 2 ways that a Mike is not going to win out of 12 methods total. So that means the probability that a Mike does not win is 1 in 6. So chances are at least one of the Mikes is going to win. Question E. Determine the probability that at least one Mike is selected. Okay, so we want at least one Mike. So that means Christine and Mike H and Christine and Mike L count. Mike H and Christine, Mike H and Mike L, Mike H and Phyllis all count. Mike L and Christine, Mike L and Mike H, Mike L and P count. Phyllis and Mike H and Phyllis and Mike L count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 ways that at least one Mike gets to go. 12 total possible items in the sample space. So the probability that a Mike is going to attend is 5 out of 6. Now, there is a special rule that we could have used for that last problem. So when they do the wording like the probability of at least one event happening, there is a little formula that you can use. The probability of at least one can be found by taking 1 minus the probability that none occur. So you can kind of think of it as a complement. So, for example, in that last question we just did, in part D, where it said, what's the probability that neither Mike gets to go? We found out that the probability was 1/6, that neither of them get to go. So you could have used that in part E. In part E, it said, what's the probability that at least one Mike goes? Well, we could have taken 1 minus the probability that neither go, and we would have had the same answer of 5/6, a lot faster. Okay, start your homework. Let me know if you have questions.